Hi everyone, welcome back to chemistry. In this video, we're gonna finish off our ionic bonding and ionic compounds, Roman numeral 3 on the study guide. And we'll finish off with polyatomic ions. So anytime I see like a new vocabulary word, I like to kind of break it down into different parts to see if I can kind of figure out what it might mean. So, and that just helps me kind of understand it a little bit easier. So poly means many or more than one. Atomic meaning atoms, right? And then ions is atoms with a charge. So just like that kind of sounds, polyatomic ions are groups of atoms with an overall charge. So they're bonded together, but overall they have an ionic charge. Specifically, they're covalently bonded together, which means, again, remember, that means they're sharing electrons. And we haven't talked a lot about covalent bonds yet, but just think of them as sharing electrons, and that creates a bond between those atoms. And then overall, they have an ionic charge. So they often consist of a nonmetal, such as phosphorus, sulfur, carbon, nitrogen, covalently bonded to oxygen atoms. Not always, but most of the time. They also usually have negative charges, with the exception of NH4+, and those negative charges tend to be 1 minus, 2 minus, or 3 minus. Any higher than that, and things tend to get pretty unstable. So they don't like to have too much of a charge if they can help it, generally speaking. There are, of course, exceptions. And then I meant to mention that NH4+ is ammonium, and you might have heard of that. It's commonly found in fertilizer. It's different than ammonia, okay? Ammonia is a different compound. So ammonium is our NH4+. So just like regular ions, right, like something like Na plus or Cl minus, we write the charge on the top right of our species, and that charge shows us what the charge is on that thing. In this case, it's a group of atoms bonded together. So you don't need to memorize everything from this table. This just shows some common polyatomic ions. The ones that I do want you to memorize, and usually I try to stay away from trying to just memorize stuff, but with polyatomic ions, you do need to kind of memorize them because you'll be working with them in the future. And in just a little bit here, we're going to be trying to figure out how to write formulas using polyatomic ions. And so you need to know these. The ones that you need to know are on your study guide under Roman numeral 3, polyatomic ions. And the ones that are italicized are optional. You don't have to memorize those yet. And I do have some flashcards posted in Canvas that you can just print off and cut out and use as flashcards to memorize, or you can make your own. Sometimes I find making my own is helpful because the act of just writing it out can be helpful. But you don't have to if you don't want to. They're there if you need them, is in other words. Okay, so that's just some of the common ones, and you'll just get used to these as we start to work with them more as well, and you'll start kind of remembering the charges, but you do need to be intentional about memorization as well. Okay, so I don't want to go too much into this, but just really briefly, some polyatomic ions end in ATE, so those are like some of the most common ones. They end in that ATE ending, so sulfate, phosphate, nitrate. And then if they have less oxygens, one less oxygen, but they look similar otherwise, like notice that the only thing different between sulfate and sulfite is that oxygen there, then they end in ITE, okay? So sulfate becomes sulfite, it has one less oxygen. Phosphate has 4 and phosphite has 3. Nitrate has 3 and nitrite has 2 oxygens. Okay, so the one with less oxygen has the ending ITE, and the one with more oxygens has ATE. There are some exceptions to the rules. So cyanide doesn't have any oxygens, so we can't really use oxygen to figure out, what to name it. So it's just cyanide. And then hydroxide, I almost said hydride, which is a different thing. Hydroxide is OH minus. And that's something that we'll work with in lab. It's a common base. So, yeah. So something like sodium hydroxide would be a common base that we use. Okay, so and then I think I'm going to skip this part. I don't think it's really that helpful, but you can read it if you'd like. I think it's actually just more helpful to make flashcards and memorize these polyatomic ions. So there's also these chlorine polyatomic ions, so chlorines bonded with oxygens, and there's 4 different ones. So I kind of like to start with chlorate and try to memorize that and as being ClO3 minus, and then remember the ATE versus ITE ending. This one has 1 less oxygen, so it's chlorite. So chlorate versus chlorite has that difference in oxygen. Whoops. And then if you lose another oxygen, or if you have 1 less oxygen, we call it hypochlorite. So remember, hyper is having too much of something. Hypo is having too little of something. So that's how I kind of remember that. And then per, I think of hyper. Whoops. So having too much of something is ClO4. That's just how I like to memorize it. But whatever works for you. So, like I said, you are going to have to write formulas containing polyatomic ions. And that's because your ions will bond with polyatomic ions, right? Because this magnesium has 2+ charge, it really wants to bond with this minus charge. It has a positive charge and it wants to bond with negative charge. Specifically, it wants to bond with 2 of these nitrate ions. Because it has 2 pluses and it wants to be neutral. Okay, so if magnesium 2+ wants to bond with 2 nitrate ions, each with a negative charge, the overall compound will end up being neutral. Yeah, but you have to write how many of those polyatomic ions you have. So thinking about, remember, what was a good example? Remember magnesium 2+ and chlorine? Remember when we were trying to bond those and write the formula? And we said, okay, if we want our final chemical formula to be neutral, we need to have another chlorine here so that we can have a 2- charge here to cancel out that 2+ charge. So we said, okay, then when we write this formula, we've got 1 Mg and 2 Cl, 2 chlorines. So we would write MgCl2. We also said you could do a crisscross method, right? Where you go like this. Oops, forgot my L. Where you take this number from here and you pop it down here, and you take this number from here and you pop it here, and then you have MgCl2. Same thing, right? But just found in a different way. We have those 2 ways of writing formulas with polyatomic ions as well. So let's do this. So if you start with Mg2+, and you want to bond it with this nitrate ion, this is nitrate. What would be nitrite? What would nitrite look like? Yeah, it'd be NO2-. Yeah, remember that ITE ending says we have 1 less oxygen. Okay, anyway, just a side note. So if we want to figure out how many of this thing we need to bond with this thing, we could we could say, okay, I want my magnesium to bond with 2 NO3 minuses. Okay, and then I can draw my Mg, NO3, and now we have to put parentheses around that NO3 if we put this 2 here. And the reason for that is that if we just wrote this like that, not only does it kind of look weird, it also makes it look like that nitrogen, like there's only one of them, and this 2 is just going to that oxygen. So we want to say, we don't want, that throws off our numbers, right? So we want to show that we have 2 of whatever's in the parentheses. We have 2 of those things, okay? So just like you would write, you know, maybe O2, and that means you have 2 of that O. If you put the parentheses around your polyatomic ion, that means you have however many, whatever number you have there, you have that number of your polyatomic ion, whatever's in the parentheses, okay? And another way, you can still do your crisscross method. So you can still take this number here and go here, right? And you can take this number here, which is just an imaginary 1, and you can go over here. So now when you write that, you've got Mg. What did we take from over here? Just the 1, right? So just 1, and I'll write it out for now. And then we have our NO3. Don't forget your parentheses, right? Because we're not separating those things. It's a whole polyatomic ion. And we took this 2 from over here, so that 2 goes there. So MgNO3, 2. And what's that saying? It's saying that I have 2 of these NO3 molecules, or NO3 polyatomic ions, and then 1 Mg, 1 magnesium. Okay, so I hope that makes sense. I promised that this would be a short video, so I'm going to stick to that. You can do this learning check real quick on your own. Write the formula for sodium phosphate. Okay, so you're going to have to find sodium on the periodic table, figure out what ion it likes to form. You're going to have to look up phosphate on your chart in your textbook and see what it looks like. And then your goal is to write this chemical formula, like just like we did up here, okay? And remember, they want to be neutral. So I'll show you the solution. And we'll move right along. So naming ionic compounds that contain polyatomic ions, the way that we do this is pretty similar to just regular ionic compounds, where we name the metal first and then the other thing second. So let me highlight that in yellow actually. So first you're going to name the metal. So like we always do, right? The metal comes first, okay? And then the next part is you have to write the name of the polyatomic ion. Okay, so sodium bonded with sulfate becomes sodium sulfate. Iron 3 bonded with phosphate. Remember that 3 means that we have a transition metal. Iron's a transition metal. It can form variable charges, so we're telling that we have 3+ charge on that iron. And then aluminum is going to bond with carbonate. Okay, carbonate's your polyatomic ion's name. All right, you can try this learning check as well. And you're picking from that list which correct formula it is. Wow, there's lots of learning checks. Try this one as well. Okay, and here's the solution. All right, if you need help with this, let me know. And then here's a flow chart just for naming ionic compounds, just now that we have all of the different ionic compounds we can make. So you'd be on, this is the ionic side, and we're going to get to this side next time, okay? All right, I hope that helps, and let me know if you have any questions.